4.5, we will be able to determine if a graph represents a linear proportional relationship by finding the unit rate. Let's begin by defining some terms. What does it mean to be dependent? What about independent? How do you think this applies to a graph on a coordinate plane? Let's take a look. A dependent variable is a value that is dependent upon or determined by the independent variable. This is represented by values along the y-axis. Your independent variable is a value that determines the value of the dependent variable. This is represented by the values along the x-axis. So for example, the distance you travel on a road depends on how long you drive, which is the independent variable and which is the dependent variable. The independent variable is how long you drive, because how long you drive will determine how much or the distance you are traveling on that road. Therefore, the distance you travel on the road, because it is depending on something, is the dependent variable. Let's draw 3 conclusions about the following graph. First, the line is represented by the equation y is equal to kx. All of the linear proportional relationships you have studied so far can be written in the form y is equal to kx. In this particular equation, the values for y depend on the values for x. In this particular type of equation, we have what is called direct variation. If we had to describe direct variation in words, we can say that when two quantities, x and y, are proportional, the relationship can be represented by the direct variation equation y is equal to mx, where m is the constant of proportionality. So by looking at this particular graph, this point is 0, 0, and this point is represented by 1 and m, which is your constant of proportionality, previously known as k. So the graph of y equals mx is a line with a slope of m and passing through the origin. So you must have a point 0, 0 on the line, and therefore your 1 point for x will give you your y point, which will be your constant of proportionality. Let's continue on. Let's identify the unit rate in this particular problem. As we said before, our unit rate is K. K, as just identified in the previous discussion, okay, can also be represented by M, which is also called slope. I like to think of M as a slope of a mountain, how steep that mountain is. So let's determine our unit rate by finding our constant of proportionality. In this particular line, we see that it is proportional because one of the points on the line is 0, 0. Now let's go to where x is 1 and let us determine what the point for y is. This point is represented by 1, 8. Therefore, our constant of proportionality would be 8. Let's take a look at the following proportion or table and determine whether or not it is proportional. We know that a table is proportional if when we apply y divided by x, our values are always the same. Because we cannot divide 2 by 0, we cannot do that one. Therefore, let's apply the next one. 6 divided by 0 is 2. 10 divided by 6 gives us 1 and 2/3. 14 divided by 9 gives us 1 and 5/9. This table is not proportional. It is not proportional because of the fact that our constant of variation are not the same. Our y divided by x is not equal. Let's graph the following table on the coordinate plane. If we graph 0, 2, we would start right about there. 3, 6, 6, 10, and 9, 14. And as you can see, there is a slight curvature of these points. What should a proportional relationship look like on a graph? As we stated previously, the line should pass the origin. The line should also be a straight line. Let's take a look at another example. Again, if we do our y divided by x, we would see that 2 divided by 1 is 2, 4 divided by 2 is 2, 6 divided by 3 is 2. So yes, the table is proportional. If we use this particular set of points, we have our m, or our constant of proportionality, or our slope, and therefore we can plug it in to our equation y is equal to mx. Let's graph our points on the table. 0, 0, 1, 2, 2, 4. Oops, I went a little bit too far there. 2, 4, 3, 6. And as you can see, these points create a straight line. So what should a proportional relationship look like on a graph? First, it should pass the origin. Secondly, it should create a straight line. And thirdly, it should have the same unit of change. So this particular line passes through the origin, is a straight line, and if you notice, from one point to the next, it rises 2 and goes to the right 1. Rises 2 to the right 1. 1, 2 to the right 1. Rises 2 and to the right 1. Rises 2 and to the right 1. And if I would have been able to draw this with a straight edge, rises 2, it would have hit that point.